Most people think agentic AI is just a smarter ChatGPT with a to-do list. It's not. It's a fundamental shift in how machines behave. These systems aren't just answering questions, they're planning, executing, learning, and sometimes even outsmarting expectations. They don't just react, they act. If you have ever wondered how AI could one day run your business, manage your supply chain, or even operate your spacecraft, it's not science fiction anymore. But you have to understand what makes them tick, because behind the headlines and the hype are a set of core building blocks that change everything. Chapter 1: The Core Instinct. What makes agentic AI different? At the heart of agentic AI is the idea that machines aren't just responding to prompts, they're initiating actions on their own. And that sounds simple, but it's the biggest conceptual leap since neural networks. Think about how you function when you wake up in the morning. You don't wait for someone to tell you what to do next. You follow a mental model, you prioritize, you adjust, you iterate. Agentic AI does the same. Within a defined scope, it has a goal, it has tools, it makes plans, and it executes. Let's break that down. Traditional AI systems like classifiers or even chatbots are task specific. You give them input, they give you output. Done. Agentic systems are goal driven. You give them a high level objective and they figure out how to get there. This requires a few things: memory, reasoning, and the ability to loop through tasks autonomously. It starts with goal representation. The AI needs to know not just what it's doing, but why. This means encoding goals in a way the system can evaluate success or failure. That could be maximizing profit, minimizing downtime, or optimizing for a user satisfaction. But it's not enough to know the goal. The system has to know how to get there. And more importantly, when it's not working, that's where planning modules come in. These modules let the AI break a big problem into smaller tasks. You can see this clearly in autonomous agents like AutoGPT or open source frameworks like LangChain. The AI builds a tree of actions. If it wants to write a report, it breaks that down, gather data, analyze it, draft it, format it, submit it, and it doesn't need human intervention for each step. It knows when to move forward, when to retry, and when to ask for help. Next is tool use. The agent needs access to external APIs, apps, or environments where it can perform actions. This is where agentic systems become more like workers than calculators. They might send emails, run code, manipulate files, or interact with other software systems. It's not just predict the next token, it's use these tools to achieve this outcome. But autonomy requires memory, not just short term memory for the current task, but long term recall of previous attempts, failures, and learnings. This is what lets agentic systems improve over time. And it's not trivial. Memory is expensive, complicated, and prone to error. But without it, you're back to square one: reactive AI. To manage all this, you need a control loop. The AI checks the outcome of each action, evaluates whether it's getting closer to the goal, and makes adjustments. This loop mimics human reflection. It's the digital version of asking, is this working? Should I try a different approach? And if done right, it gives the AI a kind of self awareness, not in the philosophical sense, but in the operational sense. What's critical here is that none of these building blocks are optional. A chatbot can live without memory. A classifier doesn't need planning, but an agent is a system that acts with intent. If you remove one piece, memory, reasoning, tools, goals, it falls apart. This is why agentic AI is so powerful, but also so risky. If the goal isn't specified well, the AI might take a path that looks efficient on paper but is disastrous in real life. If the tools aren't scoped properly, the agent might trigger systems it shouldn't touch. And if the memory is flawed, it might keep repeating mistakes, confident it's doing the right thing. So, building agentic AI isn't just about making a smarter chatbot, it's about engineering behavior. designing systems that not only perform tasks, but choose which tasks to perform, in what order, and when to stop. That's a different level of complexity and a different level of trust. That's the mindset shift. And if we treat these systems like tools instead of collaborators, we'll miss the real revolution. Because the next era of AI isn't reactive, it's active. Chapter 2: From Language Models to Agents, the Hidden Architecture. So here's the thing: agentic AI often gets confused with large language models. But a language model alone is not an agent. It's a smart engine that predicts the next word based on the previous ones. That's it. What transforms it into an agent is the structure around it, the scaffolding, the loop, the architecture that turns passive intelligence into active behavior. You can think of the language model like the brainstem. It handles the raw processing, but the body around it, that's the agent. It's made of components like a planner, a memory system, a tool set, and a feedback loop. These components can be loosely connected or tightly integrated, but without them, the model just talks. It doesn't do. Let's walk through how this looks in practice. Start with a goal input. This is the high level instruction like summarize all market trends for 2024 and email them to the team. That's not a single step task, that's a mission. An agent has to break it into chunks, so it runs a planning step. This planning usually happens inside the model itself. Prompt engineering guides it to ask, what are the necessary steps to accomplish this? And generates a list. Each step becomes a task. And here's where a critical piece kicks in: the execution module. This component takes each task and routes it back to the model with updated context. For example, the first task might be find sources about 2024 market trends. The agent may use a search API or access a database to complete that step. Then it verifies the result and stores it in memory. That verification step is where reflection loops come into play. This is one of the most fascinating parts of agentic systems. After executing a step, the agent asks itself, was that correct? Is the output usable? Should I revise and try again? This is where agentic AI starts to look eerily close to human like workflows. Because humans do this constantly. We write, we review, we redo. That feedback loop isn't magic. It's usually powered by another round of prompting. The model is asked to critique its own result. Sometimes another model is used to review the first one. This technique is called self reflection or auto evaluation. It's messy. It's not always reliable, but it gives the agent the ability to course correct. Not just blindly move forward, but actually pause and rethink. Now, let's add tools. This is where agents stop being theoretical. Because, let's face it, a model that can write a sentence isn't the same as one that can launch a script, modify a document, trigger an API, or book a meeting. Tool use is the difference between reasoning and action. These tools are not built into the model. They're connected through external function calls or APIs. The agent is told, if the task requires sending an email, use this function. If it requires querying data, use that endpoint. The model decides when to use these tools and what to send to them. That's a huge step. It's no longer just generating words, it's using software. Of course, every time the model uses a tool, it needs to understand the output. That's another challenge. The tool might return structured data, a PDF, or a JSON blob. The agent has to parse it, understand it, and decide what to do next. Sometimes it even has to reformat the result to make sense of it. This brings us to context management. At every step, the agent has to keep track of what it has done, what it has learned, and what it still needs to do. That means a memory stack, a scratchpad, or even a dedicated vector database. This memory isn't just for storage, it's for reasoning. The agent looks at past steps to avoid loops, remember facts, and improve results. All of this needs orchestration, and that's where agent frameworks come in. Open source systems like LangChain, CrewAI, AutoGen, and AgentOS are trying to make this easier. They let developers stitch these components together into workflows. They handle the loop, the retries, the memory, the error handling. They provide the skeleton. The language model provides the brain. This is critical because without that loop, you just have a fancy autocomplete. But with the loop, the tools, the memory, and the planning, you have an autonomous system that starts to look like a junior analyst, a personal assistant, or even a project manager. That's why agentic design is not just a tech stack, it's a philosophy. You're not designing outputs, you're designing behavior. You're engineering a workflow that can learn, adapt, and act across time. That changes how we think about automation. It's no longer press a button and watch it run. It's give it a mission and let it figure out the rest. And we're just getting started. Chapter 3: Limits, Risks, and the Road Ahead. Now, here's where things get real. Because for all the excitement around agentic AI, it's not magic. It's not even close to being finished. These systems are still brittle, still unpredictable, and often surprisingly dumb in how they make decisions. But that's exactly why we need to understand them better, because we're already putting them in charge of things. One of the biggest issues is hallucination. When a language model guesses its way through a task with false confidence, an agent can turn that into a dangerous decision. In isolation, a hallucinated sentence is just a mistake, but in an agent, that mistake might trigger an action: send an email, delete a file, transfer money. This is why tool use without trust is risky. The agent needs guardrails. But what kind of guardrails? Some developers are hard coding rules. Some are using other agents to monitor the first one. Others are trying to fine tune models for reliability. And in production environments, you're starting to see hybrid systems: agents that use traditional software for critical steps and only turn to the LLM for language heavy tasks. It's like having a creative intern who always needs a supervisor nearby. Another major problem is over optimization. Give an agent a goal, and it might try to cheat its way there. Not out of malice, but because it lacks common sense. If you say maximize clicks, it might start generating outrageous content. If you say minimize cost, it might skip essential steps. This is the alignment problem in a new form. We're not just aligning models to truth anymore, we're aligning them to intent, and that's harder. Then there's the issue of feedback loops across time. Agents that work over hours or days need persistent memory, but memory systems aren't stable yet. They forget things, confuse timelines, or load the wrong context. Worse, long running agents might start to diverge from their original goal without realizing it. They can get stuck in thought, endlessly refining a plan that should have been shipped hours ago. Human project managers course correct. Agents, not always. You also have the problem of scale. Running a single agent with reflection, memory, tool access, and retrieves is expensive. Multiply that across hundreds or thousands of users, and you hit a ceiling fast. Right now, most agentic AI is living in demos or controlled experiments. It's not yet production grade for high stakes use cases without a lot of oversight. Despite all that, the potential is undeniable because what we're building here isn't just faster software, it's software that behaves, that adapts, that participates in workflows. Imagine customer service systems that don't follow scripts but improvise, business agents that compare contracts, check compliance, and raise red flags, research agents that not only summarize data but generate hypotheses and test them. And this is just the beginning. We are moving toward multi agent systems, groups of AI agents working together, each with a role. One might research, another might plan, a third might write, and a fourth might verify. These agents talk to each other, they negotiate, delegate, escalate. It's not AI as a tool, it's AI as a team. That opens the door to completely new kinds of infrastructure. We'll need agent operating systems, platforms that don't just run software but coordinate behavior across AI systems. These platforms will handle memory, identity, coordination, and accountability. Just like humans work within organizations, agents will need digital environments that support collaboration and structure, but will also need ethical frameworks because when agents act, they affect people. Who's responsible when an agent sends the wrong report, or mismanages a task, or exposes private data? Right now, the lines are blurry, and we can't afford blurry lines in systems that act independently. We need better audit trails, more transparent memory, and systems that can explain their decisions. And maybe the biggest shift, the interface. We spent decades telling software exactly what to do, but with agentic AI, we'll start focusing on outcomes, not instructions. You won't say, open Excel, run these numbers, format the chart. You'll say, give me a summary of last quarter's anomalies with visuals. That's a complete rethinking of human computer interaction. That's what makes agentic AI so different. It doesn't just change how software runs, it changes how we think about responsibility, creativity, and control. And it forces us to confront a hard question. If machines can act with autonomy, what's left for humans to do? The answer is a lot. Because what agentic AI can't do yet is understand stakes. It doesn't grasp nuance, context, culture, or consequence the way we do. It doesn't care about timing, tone, or trust. It doesn't carry meaning. That's still our job. But it's a job that will look different in the coming decade. So if you're building, managing, or even just curious about where AI is going, don't stop at the models. Look at the agents because they are not coming. They're already here and they're learning to move. This is not the future of AI, it's the architecture of the present. Thanks for watching. Check out the references in the description to explore further.